Hello, people. You're looking at the New York State Regents reference sheet for physics. We're going to be using this today to do some calculations on the quantum jump. All you need is a couple of concepts, a couple simple formulas, and this thing to figure it out. So, page 3, you get the energy level diagrams for two elements, hydrogen and mercury. And I'm going to go through a problem that ultimately is going to tell what color, in quotes, light comes off of this element when an electron drops down energy levels. So let's begin. TD Bank pen, I'm ready to go. Let's say we're looking at hydrogen, and let's say that through electricity or heat or anything, an electron goes from the n equals 2 energy level, it jumps up 1 energy level to the n equals 3. Fraction of a second later, boom, it drops back down. And in doing so, it emits a photon of light. Your job is to figure out what kind of light it is. So this is the process. I know that in dropping from here to here, that the electron actually loses energy. It looks like it gains it, but if you look at that negative sign, it's actually losing it. This is a deficit of energy, is what it would take if you took an electron in the ground state, all right, n equals 1 level, gave it 13.60 electron volts, which is a unit of energy, it would get all the way up right to this level, just about ready to ionize the atom. If you gave it 13.61 electron volts, that would be enough to get it off the atom, and that 0.01 electron volts would be converted into kinetic energy and it would shoot away. That's called the photoelectric effect. That's kind of how solar cells work. But we're not going to do that. We're going to do, goes from n equals 2 to 3, drops back down. What kind of light is it? So first I got to find this difference. So it's going to be the difference would be, and I'm not going to worry about the negative sign, it's just a difference. 3.4 minus 1.51, right? So what does that give me? That would be 1.89 electron volts of energy. So that's what the electron loses. That's going to be the actual energy of the photon of light coming off of it. Before I could put that number into a formula, when we use energy, we've got to be in joules. So I go to page 1 of my formula sheet, and I can see that 1 electron volt is the same as 1.6 10 to the minus 19 joules. So let's shift that. I would say then 1.89 electron volts times 1.6 times 10 to the minus 19th. That is joules per electron volt. So these cancel out, and I end up with joules. And oh man, I'm taping this on my phone. I can't use my calculator on my phone. Hold on. Fire up the laptop. Sorry about this. All right, 1.89 times 1.6. Would be 3.024. So that would be 3.024 times 10 to the minus 19th joules. right, now I'm going to use a formula that I showed in the presentation I did Monday to convert this to what the frequency of light is, because color or type of E&M is dictated by the frequency. So I'm going to use E equals HF to figure out what this frequency is. So frequency is going to be the energy of the photon divided by Planck's constant. That's going to be 3.024 10 to the minus 19 divided by, where do you find constants? Page 1 of the New York State Physics Regents reference sheet. Right there. It is 6.63 10 to the minus 34. All right, now let me plug this in. I'll divide that by 6.63. And that would give me 0.456. I'm just rounding a little bit now. Times 10, let's say 19, 34, that was 20, be 14, 15 to the 15th, which would be 4.56 times 10 to the 14th, and that is a unit of hertz. Now, how do you convert that, or look at that and figure out what kind of light it is? You go to the New York State Physics Regents reference sheet on page 2. This thing has this photon has a frequency of 4.56 10 to the minus 14th. I look on here, where does it fit in here? 4.6, I forgot it already. 4.56 10 to the 14. That fits in between 3.84 10 to the 14 and 4.82 10 to the 14. That means that photon is red light. That's what it would give off. So, I'm going to ask you to do one problem and email it to me. I just dropped my pen. If a photon of light, an electron in the D energy level of mercury jumps up to the F, then immediately drops back down from the F to the D, you tell me. That's not an N, it's a wave. You tell me what type of light is produced. I want to see all the work just like I did there. That's it. Get that to me tonight, and we're all good.